Welcome to Espresso on Electronics, quick sips of EDA wisdom. Today we've got an electrifying topic on our hands, bug hunting. But before you think of nets and jars, we are not really talking about the insects you find in your garden. We're diving into the digital realm. How can machine learning and AI uncover the rare bins or vulnerabilities in software, which is also known as bugs? Joining me today is John Rose, a seasoned product engineering expert known for effectively deploying the cutting edge technology that we're going to talk about today. Welcome to the show, John.
Thank you. It's a pleasure to be here again.
Thanks, John. So, John, from a product engineering perspective, how critical is the role of coverage in ensuring quality and reliability of semiconductor products?
Yeah, so that's I guess a big question. So in verification, we use coverage as a proxy for how well have we verified our design, right? And it's good because we we put down coverage for all the things that we know are really important for us to verify. And so coverage is a very nice proxy for have we done what we know is important to do in our verification process. The problem, of course, with coverage is it's not complete because we don't know what we don't know. So the coverage is really only as good as what can we think of. But it's an important step, especially in random verification, where the whole idea of random verification is trying to hit as many legal scenarios as you can and doing as much interesting stuff as you can and giving the simulation as much freedom as it can have in order to find interesting things. But to do that you need some indicator that you're doing the right kind of stuff, and this is what we use coverage for.
So, John, I mean, I remember from the last podcast, and I'm sure our listeners also remember, you spoke about SimAI, right? So, what challenges have you encountered deploying the technology SimAI? Particularly, I want to know about, regarding the interaction into the existing customer frameworks and how have you been able to show the bug hunting value of SimAI, which I'm sure that SimAI is focused or can deal or help DB engineers more towards finding more bugs in lesser time or that
Right.
stuff.
Yeah, so I mean that's many questions there. Uh so the challenge of deploying any new technology, whether it's SimAI or anything else, is showing like what's the value, what is it that this kind of technology can do for you, right? And SimAI has a number of positive points, a number of things that value propositions is trying to promote. One is just making your regressions more efficient, but that's useful. But for DV engineers, that's not the most interesting thing, because at the end of the day, as I said, what they want to do is have random environments that just explore a lot of stuff. And there is some fear that if you focus on efficiency, you miss out on something. Right? Even just in a normal random environment, you can make it more efficient by just reducing the number of seeds you execute. So as a value proposition, while it's useful, that's not the main thing. What DV engineers really at the end of the day care about is, can I find bugs before I tape out? Because after tape out, bugs are extremely costly. The closer you get to tape out, the more costly they get. After tape out, it's even more costly. Um, and then along with that, we're not talking about it today, but another piece is being able to hit our coverage faster. So as we already talked, you've defined this coverage as your proxy for have you done interesting stuff. Um, you want a technology that can help you hit all of the cases that you know you need to hit, right? So the two values that resonate most with DV engineers is, how can SimAI help with bug hunting? How can it help me find bugs maybe sooner? So maybe my full regression, if I run it, long enough, it's going to find the bugs. But if I can move that bug finding, do the traditional shift left, find expose a bug a couple weeks earlier in my cycle, that's hugely valuable, because the closer you get the tape out, you don't want to be still finding bugs. Obviously, if they're there, you want to find them, but you want the bugs to have been found earlier. Okay, so that's what resonates with DB engineers. The technology can help find bugs, so that's good. And it can help if you've already found a bug. It can help you create more scenarios to get around the bug. So hit it in multiple ways. So you're not necessarily just relying on a fixed seed to replicate the error signature, right? And these are related topics, and so you're talking about bug hunting, and this is one of the things that SimAI can help with, is helping stress the design in ways that will get bugs exposed earlier.
So, what's the biggest challenge that you feel, you know, is there in bug hunting?
So I mean, so the biggest challenge is you don't know where the bug is, right? I
Absolutely.
mean, that's the problem. Like when if, so sometimes you have an inkling that there's a part of the design that has more complexity to it, and maybe you don't have a high comfort level that it's as well verified as it should be. So you may have some intuition that there could be a bug in this area because, I don't know, it's got some extremely deep states that are hard to get into, and your environment just doesn't get there very much. So that can be the case. But normally, I mean, the fundamental problem is, it's like, if I knew where the bugs were, then they wouldn't be bugs, right? And
Correct.
so, so the challenge is DB engineers is just trying to figure out, how do I do interesting stuff? How do I figure out how to stress parts of the design that have more likelihood of exposing bugs, right? And there is a lot of intuition that goes into that, some luck, and some is just brute compute, right? Let's take as much compute as our management will let us have, and let's run as many random simulations as we can get, and let's hope for the best. That's the challenge.
Okay. And John, what strategy and technology do you think, I mean, it's proving effective in improving the bug hunting process?
Yeah, so SimAI, where it is now, in the past year or so, maybe a little over a year now, we've been focusing on ways that we can leverage this technology to help in the bug hunting mode. So the technology, fundamentally, the way it works, is it tries to understand how your randomization affects your coverage space. That's what the technology does. Um, so what we've found in working with customers is that if we look at rare coverage bins, so coverage bins that are hit less effectively by the verification environment, and we have the tool try to stress those rare coverage bins, that's one way that we have the possibility of exposing new bugs, because again, we're using coverage, things that the DV team has determined this is important in some way, And then we say, okay, well, let's look at the coverage that just isn't getting as well hit. And we stress that more. And that has the possibility of exposing new failure signatures. On top of that, we've added to our technology the ability to stress failure signatures. So this is especially effective. Well, it's effective anytime in the cycle, but especially when your failure rate gets low and the failures that are being exposed, that are happening in your random simulations, are by their nature extremely rare because you're much later in the cycle. So let's say you've run 20,000 simulation runs and you've hit 3 failures, you know, 2 with one failure signature and 1 with another failure signature. I mean, those are rare events. And now what we do with our technology is we say, okay, let's let our machine learning model understand how the randomization can get into those extremely rare signatures. And let's build a set of runs that try to stress those areas. And what you end up with is a lot of runs that don't get into the exact same states that cause the error, but you get around the same error. So you may end up hitting the same error condition, but in a slightly different path. So maybe it actually exposes a new signature, but it ends up being the same root cause error. Or what you're hoping for is because you're stressing around this area that had a bug in it, maybe you find some cousin bug. Um, and what some customers are using this for, along with just the bug hunting, is okay. Now our designers have checked in a fix, and our normal flow is they check in a fix, and we verify it against the seed that exposed the bug. But that's not a very resilient way of verifying a bug fix, because that you know things may have been perturbed in the environment such that that exact scenario no longer happens. So with this technology, you now have a set of runs that are getting into that area and stressing the area. So you can run this small set of runs, small relatively speaking set of runs, and have much more confidence that the fix is good. And as I said, you're also, because you have many more runs in the area around where the bug was found, you can have much more confidence. If you don't find any more bugs, you can have much more confidence that, okay, that's a pretty well verified area now, right? It's now we can go on for other things. And so, you can now add these runs to your overall set of runs. So many customers, what they do is, in the last month or 2 months of the verification before tape out, they're basically just running tons and tons of random runs trying to expose whatever bugs are left after they've taped out, or I'm sorry, after they've closed coverage. And, you know, prior to tape out, hopefully things are stable, but you often still find 1 or 2 or 3 bugs in your random simulations. And what you want to do with a technology like SimAI is try to get those as early as you can, right? You really want those last months to be clean, but
Yeah.
running as many, simulations as you're allowed to run to have confidence.
Absolutely. This is interesting, John. Yeah. And John, I mean, you mentioned all these use cases, and I think this is very useful for DB engineers. Can you
hmm
share an example of semi-AI technology, successfully identifying a rare bin, or it helped filling a coverage hole that was previously missed?
Yeah, I mean, we've had quite a few such cases. This technology for quote unquote bug hunting is still relatively new. But even in the short time we've had, we've used it on designs. And I will say we've seen much higher effect in targeting rare failures that have happened near the end of the environment. We had a customer that they had a single failure in a regression of 20,000 runs, and we targeted that failure. And when we did that, we found another failure that, when it was um, looked at by the DV or the design team, it was found to be a new failure. So they were extremely keen. I said, "Hey, this is great. Let's go fix this." We had another customer, in fact, recently, that they're in an active project right now. Their failure rate is low, but it's not as low as what I was just saying. It's, their failure rate is I think around 2% or something like that of their runs are failing right now. But we applied the technology to the set of failures that they had, and it exposed a new RTL bug. So this is something they hadn't seen yet. Now, this is an active project, so there's nothing to say that 2 weeks from now they wouldn't have run into the same bug, right? I'm not saying this was a design escape, because who knows? But what I'm saying is, we apply the technology and it exposes a new failure. And this is something we're seeing pretty consistently. If we're on a live project and we have some rare failures that we target, we pretty consistently see new failure signatures exposed. Now, obviously, the more stable the design is, the less potential bugs that are out there, the less chance there is going to be that we'll expose a new bug. And that's just, the life. Um, but like I said, what we are seeing, and I mentioned two examples, but we are seeing that we pretty consistently um, expose failure signatures before they would have otherwise been exposed. And that's the win we're trying to get here. We're not trying to replace the full regression with this, right? You're still running your normal regressions. What we're doing is giving some focused runs that will hopefully expose additional failures much earlier.
Thank you, John. Yeah, I think everybody should start using the technology as early as possible,
Yeah,
because nobody wants those nightmares in the end of like, oh, I missed this bug, right? And yeah, at the end, when you're closer to your tape out, right?
that's right.
Yeah.
That's the hope, right? I mean, at the end of the day, the unseen bugs are kind of the thing that give us agita as DV engineers. Having a bug escape is kind of the worst thing that happens. So anything that can help to get those bugs earlier, that also doesn't have a big compute cost, right? Because you can always say, go to your manager and say, hey, give me twice as many slots on farm for the next 2 months, and then you can double the number of simulations you do, and maybe you'll find more bugs. But management kind of pushes back on that too. So compute resources aren't unlimited, and so we do want to have some technologies that can at least give us some additional confidence, make us feel like, okay, you know, there, there's still risk. There's always going to be risk because we just don't know what's out there. But any of these technologies that can help mitigate the risk are wins for the DB team.
Thank you so much, John, for sharing your insights. It's been absolutely enlightening having you on the show.
Sure. Well, thank you for having me. It's always fun to talk about the technology.
And thank you, our listeners, for tuning in. So keep your circuits connected and ideas flowing until we meet next on Espresso and Electronics. Stay innovative.